LinkedIn and YouTube audiences, and then we'll begin the session. All right. Very good. And welcome everyone to our career masterclass, Preparing Your Career for Machine Intelligence 4.0. And our guest today is Prasad Chitta, who is the AI and ML practice lead in the banking, financial services, and insurance sector for Tata Consultancy Services. And I will introduce him shortly. But first, for those of you unfamiliar with WebEx controls, please enter your questions for Prasad into the Q&A. I will collect those and get those to him during the Q&A portion of the webinar toward the end. You can also direct the chat to all panelists, so we'll see that. But we generally will hold the questions until the Q&A section. And we'll also be doing a couple of polls during the webinar. So I'd like to start with this first one, and bear with me while I get it started. So this first one is just basically about you and your level of experience and how you're feeling today. We do that second question to check in with people during the pandemic period, see how people are holding up to the stresses of lockdowns and booster shots and things like that. So just take another few seconds and respond to the webinar question. And here we go. So I'd say that this audience, as you can see, is weighted toward people who are still at the school. We do have the next largest group of people, about a quarter, who are seasoned professionals in the 10 plus years of experience category. And it's good to see that most of everybody is either doing well or doing okay. We hope that the information in this webinar will help to improve the outlook for people who are not feeling as bright today. So with that, I'm going to go ahead and introduce Prasad, who, as I mentioned, is the AI and practice manager, AI and ML practice lead, rather, at Tata Consultancy Services in the banking, financial services, and insurance sector. digital solutions architect, a data philosopher with nearly 3 decades of experience. And he provides high-level services to global enterprise customers in machine intelligence, which is one of the fastest growing and most exciting sectors in the digital economy today. So welcome, Prasad, and thank you for being here. And you're on mute, so you might want to unmute yourself. There you go.
Thanks, Stuart. So welcome everyone to this webinar. I will share a quick few
just
slides.
a moment. Here we go. There you go.
Yeah. So yeah, before we start, so this is not much of a seeing content. It is more to hear, listen to it, and try to understand the current industry, where it is going, and to see how we can prepare and what is happening in the world. So we look at preparing yourself for the new normal. New normal or the machine intelligence 4.0. So typically when we put these version numbers at the end of the at the end of anything, so it should have a context. So we'll try and understand a bit of why it is 4.0 and how it is changing the careers and how it is impacting different roles across the industries, and what we can do to kind of prepare ourselves into this 4.0 world. So we will at the end of the session, you all will understand what is MI 4.0, and then what are all the skills needed to make machines intelligent. Then I will provide you some kind of a small self-assessment framework saying that how to look at driving one's own career in this arena of fourth generation machine intelligence, and readiness and transforming for experienced professionals, how they have to look at it. Are there either people coming from a different industry or a different career path into machine learning, machine intelligence, or freshers who are trying to, that is the majority of the population I see from the poll. So that is what we will achieve. That before we go into certain questions and answers, you can, whenever you have a question, you can put it to the box. We will address them as they come once we finish the discussion about the basics, what we wanted to cover here. So the context of what is 4.0, many of you may be aware that there is a industry 4.0 which is going around. So the first stage of industry is a mechanical revolution started by the steam engine, invention of the steam engine. Then the second one is an electrical revolution, the electricity going around and making mechanical devices work without steam. So that is the electrical revolution. The third one is the internet or the information revolution, where the information is available everywhere. And the fourth one, there is no name to it. That is called fourth industrial revolution. I like to call it as cyber physical systems. So basically, we are connecting the systems to talk to systems, people to talk to systems, and system to talk to people. So all sorts of connections are happening, and uh, we call it as industrial IoT, machine learning, cloud, all these social media connecting on the networks, massive online courses helping everyone. All these things put together, it is the fourth industrial revolution. It is combination of bringing cyber physical systems together. So parallelly on the globalization and the political scenario, we have the collaborative environment, then the rise of patriotism, make my country great again, this kind of campaigns, and there are several fair economy, environmental concerns, social and work impacts which we see. We call this political and economical system scenario as globalization 4.0. So that is also is available there. Then came the pandemic, what we are going through. There are multiple waves of pandemic we are seeing, and all the work moved to remote. So this is the current context where we are in. So then we generally, to handle this, businesses who are looking at taking this fourth generation industry in fourth generation globalized environment, they have to get their machines work intelligently. So machines could be software systems, robotic systems, whatever it is. So what are the the four generations of intelligence? From the beginning of software field, we see machines being intelligent. So the first generation intelligence is programmed. So what people programmers have done is they have written several decision making statements, if then else, while, some loops and stuff like that. So the decisions are taken based on the programmed constructs. Then to improve the intelligence in the machines, there came the ERP systems, SAP solved the world, and Oracle systems. So with a configuration, how it has to behave, the behaviors of the systems have changed. So that we can call it as the second generation of the machine intelligence. Then came non-programmed intelligence. So this is where the machine learning, machines started learning from the examples. Instead of a programmer programming explicitly what is to be done, a programmer has shown the past examples of the data, and a program learned what to do with that data and apply the same knowledge. When the similar data is presented to it, it will predict a score, or it will tell what is to be done, what decision need to be taken. That is what typically known as machine learning, or the data scientist driven machine learning. Those are the three generations of machine learning. But for the fourth generation, what is needed is we have to remove or reduce the dependency of data scientists creating these learning systems. The cloud, the providers now coming with a concept called AutoML, automatic machine learning, and continuously learning, generating multiple learning models and multiple learning agents, and teach each other in an automated fashion, and make the whole process autonomous. That is the key thing where we are moving on to in the fourth generation of the machine learning. So overall, the goal of fourth generation of machine intelligence is to develop learning machines from multiple methods of learning. There are methods of supervised learning, unsupervised learning, semi-supervised learning, self-supervised learning, and continuous basis to extract knowledge and use the knowledge to build on that knowledge to make machines behave intelligently, adding the cognitive capabilities like vision, language understanding, language generation, all these things, putting them together into one place and making them autonomous and continuous learning machines. This is the goal of fourth generation of machine learning. So let us move quickly to see what is the impact of that MI 4.0 on different job roles. So typically what is businesses are looking for employing this automation for two things. One is to improve the selling, remote selling, or taking the products to the public. Two is once we sold a product or a service, make that product or service is available to that, deliver them, service them, operational efficiencies, how we can efficiently achieve the operations right from logistics to customer service. In this process, how do we make use of the fourth generation machine intelligence? And most of the software jobs. So basically software aids different business functions to become more cognitive, more intelligent, and more efficient. And all the projects within the software are being managed in an agile fashion. So there is nothing like a waterfall model of software development. Most of them are gone into the agile fashion. Everybody is doing a sprint, developing products, developing full stack developers, automated DevOps. These are all the standard practices in software project development. DevSecOps or whatever, the integration of operations and development together, testing everything in one pipeline. So the cyber physical systems are in demand. So production of these cyber physical systems is happening with a continuously evolving technology. We have seen PyTorch, TensorFlow, multiple tensor processing systems, GPUs, TPUs, different types of processing units, the algorithms like gradient boosting machines, backpropagation, second order methods, and a lot of research in computer vision, and also in the natural language processing are the big companies. The large social media companies are pioneering this work with multiple language models, bidirectional transformers, and stuff like that. So as a overall movement of the career, like full stack development was the trend until a few months ago or few years ago. So the back end, front end developers, all these things are merging into something known as a full stack development. Now the trend is moving to something called full stack deep learning. So currently there are roles like data scientists, machine learning engineers, uh, data engineers, or stuff like that, who are handling the data pipelines, who are bringing in the data from the source systems to the learning systems, and those who are making the learning systems work, and those who are actually developing the science behind them, applying statistics. So the whole of this is going to converge into something like a full stack deep learning. So that is the impact on the job roles going forward, in my opinion. Need not be a industry opinion from what I see. Then how do we train machines to be intelligent? So as I mentioned, there are things, the business challenge is the first bit here. So businesses wanted to improve their key performance indicators. They wanted to optimize, they wanted to innovate, and they wanted actually to be excellent or beat the competition and be excellent in their own business. These are the key challenges. They drive uh, certain tools to actually process, stream, store, and learn from the data. Data which is structured, which is unstructured, which is pictures, or which is blog posts, news articles, market movements, whatever we look at as. All this data is publicly available, and with cyber physical systems, lot of IoT, right from everybody's shoes and health monitoring devices, wristwatches, and these things, collecting the information, pushing into the cloud. Information is available with the consent. Somebody signs into a service, somebody accepts that their data can be processed. How do we make best use of that data? So the enablers for that are the actual people, the intelligent people. Typically programming in one of the languages, try to write the intelligence in a programmed way. Now we are writing, or we are trying to train the machines to be intelligent. Let the software learn. So I see different people, the researchers who are researching on a deeply into one subject. How can I improve object representations of a picture, or from a video? How do I get a three-dimensional object representations from a video to aid a self-driving car? This kind of research is happening in the academic institutions and the bigger labs. Then we have these seasoned data scientists who are aware of a business domain. There are ML engineers who can make the tools and platforms work. They can install tools, they can make the platforms piping done, and they can get the data, they can get the training, they can validate the models, do the feature engineering. All these are the different skills of the ML engineers. The data engineers are helping to convert the data to model ready, deal with the raw data, and convert it into something, a model ready things. So beyond this, what are required? Some soft skills are also required. The storytelling, and some hard skills are also required. The fundamentals, foundations of statistics, um, linear algebra, understanding how business operations work, what are all the complications of running a specific logistics business, or a insurance business, or a bank, or any other business. What are those KPIs? Also understanding the architectures of the systems, software systems, how the software works, are supporting hardware, cloud, data storage, and stuff like that. So what all these things are trying to do is to analyze, visualize, make sense of, create graphs, or create semantic understanding from the raw data, enrich the data, make it understandable both to human beings and the machines. So that is the challenge what we have. Lot of unstructured data. How do I make it meaningful, structured, and put it into a pipeline through and learn and do the predictions, prescription, describing the data, and generating intelligence from it is the crux of it. So there are algorithms, obviously, on the platforms, tools, and algorithms as we talk. right algorithm to right type of data, how we can fit all this together is the key ingredient or the skill of the all these enablers are the roles are the people who will play this important role of making machines intelligent, and that too autonomously intelligent. Then I will provide a bit of a assessment framework. You can self-assess yourself basically using this framework. So there are a few criteria I have listed, which I think are very important for this fourth generation machine learning on this column, and the levels of maturity, what you think where you are. So don't just choose a career because it offers you good monetary value. Because this you have to be with that career for at least 20-30 years. As we work through these area. The future is definitely into the machine learning, machine intelligence. There are going to be more intelligent machines. So it is what is required here is the passion to certain level of maturity of the skill. So the combination of the skills are very important. So I am a statistics specialist. I do my PhD in statistics. I can solve anything in the a statistical problem. That alone will not help. That need to be combined together with an amount of either programming language or an amount of operational knowledge, of domain operational knowledge, to put together all these things and give an impactful solution in the area of machine intelligence. So the fundamentals are the statistics, linear algebra, and the basic knowledge of how the algorithms and optimizers work in using numerical methods. How do we optimize a mathematical equation to get to a best possible solution, and what type of data structures can be used to make those algorithms more efficient? How do we deal with huge amount of data? So those are the fundamental things. Coming to the programming languages, there are functional programming languages like Python. So the evolution of programming languages is from the standard C, C++ to C to C++ or Java, the object-oriented languages. Then we have more functional languages like Python. So the functional languages give more natively support to learning, and dynamism are required to program the machines to learn, take that dynamic learning. Then on the business side, understanding of business processes and operational tools used in the automation of learning process itself. Then visualization, uh, the communication skills. That includes the user experience, understanding what type of user experience is needed, how the intelligent machine can communicate well with the other machine or other person or whom we are dealing with, that user experience. So predominantly there are two career streams. One is the data scientist focused. Data scientist is a domain knowledgeable person. The problem solving is there in the data scientist thing. And ML engineer focused is more a technology oriented, making the platforms work, making multiple clouds come together, providing the right security, connecting all the pipes and making the whole learning process work. So these are the two primary streams, but they converge at some point in time as a full stack deep learning engineer or something like that. So take this framework try to see where you are, how to fill the gaps. There are various ways of doing that, which we will discuss in a while, and move the career into the machine intelligence. So, okay, for the freshers, the simple suggestion is to take the fundamentals in the statistics, probability, linear algebra as the first step. Then go on to learn a programming language and tensor processing frameworks like TensorFlow, PyTorch, Scikit-learn. There are other tools are available. Then get into a specialization of one business domain or a problem domain, a NLP process. So try to make language understood and sentiment, kind of deriving the sentiment from the language or the text, blogs, summarization, that kind of set of projects or that kind of skills, or the computer vision based skills, or into enterprise structured data based forecasting, market data analytics, risk analytics, fraud management, that kind of things. So what freshers can do is learn hands-on learning. Use the competition sites like Kaggle. That is one of the suggestion. Along with the theoretical learning assignments, get on to some competitions. Use publicly available platforms like Google Colab. Everybody is using, but make best use of them. Go through the courses which are available online to upgrade the skills. Obviously, there are several courses which are available. You can choose based on your own self-assessment, saying that where you wanted to go. Then don't do one-time assessment. You have to continuously look at assessing yourself once in 6 months or so. That is how the whole thing is changing nowadays. And also there are a lot of open data sources, and there are a lot of data science for good kind of a thing where you can participate and provide solutions to the tough problems. Sometimes the problems which are available in the public domain with the government data and stuff like that. So this is how you can make yourself ready for an industry job. Getting some experience of practically solving a problem in using machine learning. It is not theoretical machine learning. I know statistical methods. I can do a logistic regression. I can fit a model here. I have done a standard project, quote unquote, in some pothole detection on a road or something like that, which are typically available. A lot of code base is available on GitHub. So that won't help much unless you take a problem, take a data source, and try to fit your own model, optimize your model. You will see the different steps of making machines learn and making machines learn continuously. Then comes the area of how experienced professionals can move their career into the fourth generation of machine intelligence. So we can see the different people who are on the edges of this machine intelligence trying to come into the core of the MI 4.0. So data analyst, business analyst, current analytical roles are one thing. So the analysts, they need to focus on learning algorithms and a bit of programming to become data scientist. So from a business analyst to data scientist, the gap to be filled, or the bridging that whatever understanding of the algorithms, at least mastering few algorithms, for example, a gradient boosting machine. So people can try and understand how what is boosting and how the boosting machine will work, and then from there you can further move to a much wider problem solving model. So currently people are data engineers, probably doing ETL, bringing data from one source system, transforming it, putting into a data lake or a data warehouse. They can actually learn tools to do learning platforms on cloud, various learning platforms, making them work, the ML ops pipelining tools, experiment tracking tools, model management tools, model deployment and packaging frameworks like Django, Flask, and most importantly, the Dockers, the containerization, and the Kubernetes, the clusters, how to expand the clusters, how to deploy a code on the cluster, execute on the pod, and stuff like that. So they can become ML engineers by doing that transformation. Then comes, okay, already I am a ML engineer. How do I become much higher on the ML architect or a ML solution provider? A combinatorial skills between that. This is the pathway to the full stack deep learning kind of a model. So understand deep learning. So what are all the different layers, different types of neural networks, uh, recurrent neural networks, LSTMs, and various other neural networking based algorithms, how to train a pre-trained model, how to debug some of the deep learning training code or whatever it is. And on a larger scale, into the overall end-to-end MLOps things. Moving that, you can move into a ML architect role. So one thing I wanted to cover is if people are coming all the way from completely different domain, like either a civil engineering or any other business operations or stuff like that. Definitely there is a scope, because for the from the business or domain aspect, a data scientist is having a scientist and data together. So you can be an expert of some field or a scientist in some field. You acquire the data skills and convert data into a machine learnable features and features into a representation of knowledge, and that knowledge into insights which can drive some business decisions. So this whole process, any transformation can help be either a data engineer or a ML engineer or a ML architect or a full stack deep learning developer. So there are a scope. So you can have to use the same assessment framework and see where your passion is driving you to. So you choose a career that where you are passionate of, where you wanted to add value into this intelligence pipeline. So you can take that and move on to there. A lot of courses are available, so you pick it up from there. So that is what I have as a monologue. Now I wanted to open it up for questions.
That's wonderful, and thank you for that overview, because that takes us kind of all the way into what practical steps people can take to become professional in this area. And I like the fact that you covered the transitions from other areas as well. So I have some interesting questions. You mentioned enablers, things that will help people become or develop their skills in machine learning and machine intelligence. And Ganesh asks, if you don't have access to those enablers, is there a way to start your project? What path can you follow? And is it possible to develop a fully functional MI system on your own?
Okay, it is not possible that way. So definitely you would need a set of people who will define the project, who will define the goals of the learning and where the data is coming from. These two things are required. A data is needed, a pipeline of converting this data into machine learnable vectors. That is what we call them as. From these vectors into a learned representations of that data. From those representations, you will actually make, that could be a graph or a deep learning model, what we call. So to do this, there is not one person is suitable. There are cloud is involved. For the training, you would need a lot of GPU acceleration and stuff like that. It is physically impossible to have master all the skills at one shot. So you need to be a very good architect of the hardware. You need to bring the right software tools. So there are specialists in each area. But yes, you can pick up skills from all the areas. That is what I call ML architect or a generalist. And then specialize on something. So this that term I use is typically a versatilist. So you have to be a specialist in one area, but you have to gain general knowledge about across the whole pipeline, so that you will become a versatilist in the story. Then you can develop multiple skills over the working experience. So that is how it is. You cannot, one person picking up everything is a long drawn learning process.
We do have some questions about clarifying the relationship between machine learning, deep learning, and artificial intelligence. And you called this area machine intelligence, which implies that machine learning and artificial intelligence are
Right.
fairly integrated, right?
Right. So
Yeah,
I understood the question. So basically, there is a small distinction between artificial intelligence and machine learning. So what is the distinction is artificial intelligence. The moment we say AI, what comes is cognitive computing. So bringing a machine the ability to see things, that is called computer vision. Bringing a machine the ability to understand language, that is NLP. This is AI. There is no intelligence derived from it. So intelligence, that the machine learning is something where a area to kind of make machines learn, looking at examples. This is where the algorithms will come into the picture, like GBM or deep learning networks, autoencoders, etc. So what we try to do in Machine Intelligence 4.0 is to bring these two things together. So we focus on automation, but at the same time we focus on the representational learning. So basically we wanted to convert, or we wanted to converge these two disciplines together to make business impact. So if you are a researcher, you can purely do AI robotics research. How to make a robot more functional, how to move a particular robotic arm more naturally. So that is the AI side of the story. Then the ML side of the story is more of the gray cells, what our mind does, right? So it will take all the data and try to make a representation in the mind and create, you can call it as associative learning, neural networks, or the graph based learning, graph neural networks, graph representations,
yeah.
semantic graphs, etc. So that is where the distinction is. There is a scope for both fields, but there is much more impact when you bring them together into MI, machine intelligence 4.0.
Okay.
Yeah.
We have a question about applying machine intelligence to digital marketing. And I think you touched on it in one of your slides about the notion of product selling and that type of thing. But could you expand on that a little?
Right. So basically, the digital marketing is a optimization of how do you go and target a segment. So it is a machine learning. It will come as segmentation. So it's known as customer segmentation, and there is something called as propensity. So if I have a product of these features and I have a group of users with this kind of requirements, can I target this particular product to those people? So the features can change. I may have developed a slightly different product. So if this product is sold somewhere, I can sell this product or not. So the knowledge which is derived from the historical information of what goes together with what can be used to target such and such product, such and such new product to such and such new segment, or create a segment where to target. All these are predominantly known as segmentation algorithms and propensity algorithms. So these algorithms can be used. Machine intelligence can help your digital marketing campaigns.
That
Yes.
kind of relates to a couple of questions that came in from people in other areas. So the person who asked about digital marketing is David, who is interested in knowing how an experienced digital marketer would fit into machine intelligence. We have a question from Kasi, who is in civil engineering and would like to consider a shift into ML and AI. And we have a question from Naga, who is in software quality. So you look at these people from different domains.
Domains, yeah.
Yeah, and
So
go. Yeah, I mean, what would you comment on the transition from different domains into machine learning, and what strengths should these people focus on
yes,
bringing into the field?
yes. So there are two, as I said, there are two streams. So if you are people are coming from a domain, either it is a QA testing or from a digital marketing, whatever it is. So there is a current way of working things, right? There is a campaign being done. There is a present way. This is how I will do my work. Here, if you wanted to shift into a data scientist role, you have to look at a logical solution. How this task can be improvised, optimized using data as the ingredient. Okay, my historical data I will take this external source of the data. By bringing in these data streams together, I can achieve this in a different way. I can actually reach to more people by using this kind of additional data, maybe feeding this social input into this my current campaign model and then taking it to on that channel. So you optimize a channel, or you become a solution person. So you find solutions to the day to day problems you are facing in your operations. Then try to find a try to find an intelligent solution which is derived from the data. Then you can come into experimenting with a data based experiment and become a data scientist, pick up some tools or programming languages, auto ML tools or whatever it is, because there are absolutely no code machine learning available. There are studios and stuff like that. You show your data, you just ask the studio to develop the model and give the results to you, it will give the results. If you can interpret those results and use those results in your business process, you can term yourself as a data scientist and help your business grow using data. So this is the suggestion I will give you. You don't try to come to a technical learning Python, writing code, doing something. If you are coming from, especially from another field into this thing. But if you are already in technology, you know one programming language, it is better to pick up Python, better to pick up few TensorFlows and PyTorches kind of a thing, then become an engineer to develop the systems. So development of the systems is a different career than defining what is to be developed. That is the data scientist role.
Okay.
Hope that answers these combination of questions, not specific to one question, but yeah.
And you had touched in your presentation a couple of times about a distinction between a data scientist and a machine intelligence, machine learning engineer, and the different focuses of the two disciplines. Could you kind of go back to that and reiterate that or clarify that again?
On the difference between the data scientist and the ML engineer, right?
Yeah, I mean, you did make a distinction between those two paths, and so if you could
Right.
kind of.
So from a business analyst to a data scientist, it is more logical solutioning. Logical solutioning in the sense when we look at what algorithms you can use and how you can derive that inference. For an example, if I am doing a market risk kind of a requirement, I wanted to understand how risky is a given market. There are currently a set of calculations. There are currently some methods are used to say, okay, this is the market risk I am in. I have invested on 4 different assets, and each asset has so much risk. And what is my total risk? How much I can take? So there is a known calculation. But there could be a news sources giving some additional information to us. So there may be some news articles which are coming in talking about that company. Are they getting into some kind of a legal troubles, or what I think is the best possible asset probably may not be the best possible asset with the emergence of new information, new streams of information. So if I pick that stream of data, add another risk factor to it, and create a new model altogether. This is the data science. So I am looking at an opportunity of having availability of new stream of data and making use of that in my business process. So I am improving my business process, my understanding of this market risk, adding one more dimension to it. So now comes ML engineer. ML engineer, what he will do, he will pick up that news feed, convert the text into a set of tokens, write a program to make it understandable and give that score saying that this is now 8.9 or this is now 9.6 or this number comes into the picture. So to do this plumbing and actually getting it to this number is one stream of career. And taking this, defining this number and using this number in how do I use this number in my decision making is the data scientist role. So now I need a new number now. I wanted to get one more number. That is what he will define. Once that is defined, the right source is defined. From converting that source to this target is the engineering job.
Mhm.
Hope with this example, people will understand what is these two distinctions,
Yeah.
two roles.
So we have Janavi, who is studying machine learning and taking steps towards becoming a machine learning engineer. Um, so his question specifically is, after learning some models of machine learning, what would be the next step towards developing a machine learning engineer career? Should he start with NLP, or should he go into
Okay.
DSA, or what are the
So
process? What are the steps?
having understood some models, the next step for a ML engineer is to get on with some ML ops. So how do you track your experiments? How do you train your models with different hyperparameters? When you are training these models, how do you store those models automatically? Then how do you choose the right model finally? Then package and deploy it, make it as a API so that somebody can consume this. So if you develop that skills, you can become a ML engineer end to end. So uh, for a ML engineer, it is not really important to know all possible algorithms and how to make best accuracy in an algorithm or best generalization of learning in an algorithm. All that a machine learning engineer should know is what are all the different types of algorithms. There are some standard statistical algorithms, there are random forests and XGBoost of scikit-learn. There are TensorFlow, Keras models, there are PyTorch models, there are neural networks. So these are all multi-threaded, different types of models. These models can be stored in this way, they can be retrieved in this way, they can be trained in this way, they can be retrained in this way. So that is the skill you have to develop if you want to get into a engineer role. The same thing, if you wanted to specialize on the data science, you need to take one set of algorithms like NLP and develop more skills on the natural language processing. How do you deal with mixed language? How do you convert this language into vector? How do you do natural language generation, summarization? What are all the generative networks? What are all the summary GPT-3s? What is happening in Facebook? What is happening in Google? What is BERT, Robot, Albert, all that things. So you can specialize on one particular set of algorithms if you want to be a more data scientist. Or if you want to be an engineer, you have to take the pipelining tools. You have to take the tool A, tool B, tool C, and combine these tools and make it work on a cloud, or understand cloud architecture, combine that knowledge. I think it answers several questions about, again, what are all the skills they have to go with higher level of importance.
Yeah. I have an interesting question from Prasad, who is looking at how to extract data from the internet for use in machine learning or machine intelligence.
Right. There are two types of extraction. One is the scraping. So scraping is like you go onto the internet like with a bot and then go and browse that site and keep getting the data. There are data providers who will do that work, summarize that data and provide. For example, there are news feeds. They go through all the news publications and summarize the data and start giving you. There is an amount of money you pay to those provider and get the data. So similarly, market data feeds are available. So you go to a market and get the feed. So there are two ways. One, doing it yourself. Write your own bot, go like a user, scan through that web page and get the extracted data and then process it, what is there in it, and keep moving. This is one manual way of collecting some limited sites or sources, or you can use APIs on Twitter, social media to get the data, or you go and buy this data products from an aggregator, people who aggregate this data and sell it.
Okay. And I think our exit question is going to be for people who are not in a technical background but would like to explore careers in machine intelligence. What would be the first preparatory training or courses that they should take to develop that foundation and maybe assess if they've got the aptitude for it?
All right. So basically, machine intelligence or the machine learning is training, teaching. So if you want to teach a machine to learn from examples, this is what is the core skill. Okay, there is an example data, there is called labeled data. So you get that this means this. So it is a A to B mapping is available. And now we wanted to make a machine learn this A means this B. So this is what we wanted to do. So fundamentally, it is instead of saying if this is equal to this, do this. This is typical programming. So normally computer science careers until now are the programming careers. People have written huge long programs. If you see this kind of an input, you do this as an output. So the people have developed several things, how to show, present it and everything. So the data storytelling, so understanding data. So it is more about understanding data. If you can see data, you can fall in love with data, then you can think about, yes, I can use this data. Now I need tools to make some insights out of this data. So you should be a data person first. Some question I see in that, why freshers are asked to do data analysis even if you want. If you don't know how to analyze data, if you don't know what is a correlation, if you don't know if something is going up, the other variable is going up or not. So whether there is a dependency on two variables or not. If you cannot do that manually with human intelligence, it is very difficult to train a machine to do it.
Yeah.
So first we should know how to train ourselves from the data. So if I see few facts, I should be able to derive some intelligence from those facts.
Okay.
The same
And
way applies on the system. Yeah.
okay. And programming languages are not the uh, primary concern in
Right.
moving
So
into this.
very old programming, old in the sense standard structured programming languages like C, Java, they can be used for some up to some extent, but predominantly the modern functional languages you can take Python, Kotlin, Haskell, all these things. What they give you fundamentally is you can actually deal with a function, behavior as an attribute. You can pass a behavior to a function, and that function can use the behavior and learn itself, and actually you can self mutate your learning, you can return back your new behavior.
Mm-hmm.
So what is learning? I have a way of doing things. I see a new example contradictory to my current understanding, so probably I have to change my behavior. How do I represent this changing behavior? As a function. So if I can write a function which can change its behavior, then that becomes a natural way of programming for learning. So
Yeah.
that is given by the functional programming languages. I don't give a specific preference of Python over Kotlin or Haskell or something else. But yes, you need to have this functional programming or changing a behavior in a programmatic way. I don't need to intervene and rewrite the code. So if I
Oop,
have to rewrite the code like that, then we will be in the trouble. So hope that gives the answer to the programming languages side of machine intelligence.
yeah. I apologize for my cat crossing in front of my camera there, but I did get just a last couple of quick questions from our live stream from YouTube and LinkedIn. I think one from LinkedIn, Ritik, is asked if strong analytical skills are required, and I know that you just answered that. So I'll move on to the other one, which is from Ronaldo on YouTube. He just asked a classification question. How do you know that the problem that you're looking at requires a machine intelligence solution rather than just an algorithmic, um, standard approach to
Okay,
programming?
right. So when the problem or the issue with models are they are stale. So we show 100 examples and and create a model. So if we put this model somewhere, this model is not moving. Means it has understood only the past 100 examples, and it is
Mhm.
predicting something, right? So if that is okay, if your 100 examples cover the full gamut of things, you don't need any higher intelligence. Is it clear? So that is the clarity we need to get. But the real world is not like that. Daily new things are coming. So if I create a model, that model becomes stale next day because some new data has come, that are new inferences can be drawn from this. So we need a continuous learning machine. So what we have to do is we have to create an algorithm or a sequence of algorithms which can understand what it is processing, intelligently decide whether it has seen or not seen that data, learn from that data, update itself. As I just said, my behavior should change with the presence of new data. After you ask the question, when I answer, this answer should go into the learning, and the next question should be better than the same question. So we are not asking the same question again. That is what continuous learning needs. That is where MI 4.0 will come into the use. So that is the simple decision. You have to, whether you need a simple decisioning engine, which you know all the input combinations, you can make a one decisioning engine and move with it. But if you don't know, there are several unknowns, there are fuzziness in this. Still, we want machine to process that data. That is where you need to bring in continuously learning machines.
Great. So with that, I'm going to apologize to everybody whose questions I could not get to in the time that we have. We've already gone a little bit over our hour, so want to thank Prasad for his patience and generosity with his time. And I'm going to go ahead and close out the webinar with another poll. And this one asks people, what are you most interested in learning? Again, if you're watching on live stream, I know you can't answer the poll through the WebEx widget, so you can put in your answers into your comment stream on your LinkedIn or YouTube channel. So, and hold on a second, let me launch this poll. I was on the wrong one. Here we go. And we'll give about half a minute for this. So we've talked about data science, artificial intelligence, machine learning, and the integration of the two into machine intelligence. Talked about data engineering and the need to understand cloud computing, the need to understand DevOps and related fields of MLOps, DevSecOps, things like that, and project management as a meta skill involved with that. So these are some of the areas that relate to today's topic. Of course, there are many other areas in digital economy skills, but I'm going to share the poll results now. And not a surprise that the largest contingent of you are interested in learning data science, artificial intelligence, machine learning, and those skills. So it's also interesting to see that about half of you are interested in starting right away. And given that so many of you are at school currently, that would mean that you're already in the process. But thank you for that. I'm going to once again thank Prasad for a really excellent presentation and discussion. And I hope that everyone in the audience got as much out of it as I did. Here is his LinkedIn information. I will put that into the chat window so that you can go ahead and connect with him. Oops.
Yeah, so you can send me a message if you have any specific questions later on LinkedIn. I am open, available on LinkedIn. Thank you very much, Storett, for your wonderful anchoring this session and the introduction which you have given and everything. Nice doing this.
Thank you.
Hopefully, it has been useful to some of the people. There is a lot of scarcity of these skills, real good skills. So normally what I see is people know a bit of Python language, a little bit of data science fundamentals, few algorithms. That is where we see people coming in. If they prepare themselves more into the ML ops, little deep into the deep learning, it will be very useful when they come into the industry. and we can make the best use of training the machines, making machines intelligence, thereby the whole world better. The fourth generation of industry and the globalization, a better place for everyone in all the fields. So that is what we are looking for, a better set of skills, more quality people coming into this career.
Thank you so
Thank
much.
you very much. Yeah.
And wanted to let everybody know that I have dropped into the chat a link to Simplilearn's training courses and programs so that you can check those out. And I'm also putting in the link now to our next webinar next week, which is a general career webinar by a leading career advisor and career coach, Lieutenant Colonel Prem Voss. And it's on secrets of successfully navigating potential career pitfalls, because as we envision our career going forward, wherever we are, from the fresher to the experienced professional, we have an idea of what's next for us and how we're going to take the next step in our career. And then something else happens, the real world intervenes. And as the musician John Lennon once said, life is what happens when you're making other plans. So this session is about how to anticipate some of those pitfalls, but also how to deal with them when they do arise. And I think it's a valuable session for you. So we hope to see you next week, and we hope to see you at future Simplilearn webinars and events, and to welcome you into our learning community. You can track us on social media at Simplilearn on Facebook and Twitter, and Simplilearn on LinkedIn. And with that, before my cat knocks over my webcam, I will end the webinar. But thanks again to Prasad and to everybody for being here, and we'll see you soon.